Pups. Get back, buddy. It's okay, Bubba. Nothing. Okay, it looks like some folks are here. I'll go ahead and get started here in a second. I'm trying to see who's what. Looks like there are 4 people watching, so that's a good sign. So let me go ahead and make sure all my stuff's in order here. Again, sorry my eyes are darting back and forth. I have 2 different screens I'm looking at. Trying to get things straight. At least our stream health looks good at this point. Okay, so I'm watching the chat over here. Remember, there's a delay from when I say things and then when you're going to hear them. So there may be a little delay on that. Okay, so let me go ahead and record this. That'll take a second to get started recording. I am watching the chat on the YouTube channel, so if you have a question or something's not working correctly, then make sure that you post it there and I'll be able to see it. That's why, again, I'm looking back and forth. Okay, the first thing I wanted to talk about is the team composition. I did get emails from some people having a team or not having a team. Seemed like that was causing people trouble. In the past, this course has met in person the first time, so therefore people could kind of group up. I also made the assumption that a lot of you were in classes together, and apparently that's not 100% correct. So what I have so far is that Katrina and Orville are a team, and that Arnold and Steve are a team. So I just went ahead and randomly distributed everybody else into a team. So Joel and Robert are a team. Billy and Cynthia are a team. And Stephanie and Patrick are a team. Okay. So if you have other things already worked out you're working on, then let me know and we'll figure stuff out. But that at least gets you started. Everyone should be checking their Gmail and also their Tusculum mail. So everyone can get through Moodle, I think. At least you can look up other people's Tusculum email. If you want their Gmail, let me know and I will give you that information. Okay. Let's switch back over to the chat to make sure no one is saying anything yet. Okay, so they're up to 6 watching now. That's a good thing. So the teams being slow to develop means that we can take an extra week. Not a whole week. If you look at the assignment on Moodle, which I put out there, I think I'm giving you until Wednesday, something like that, to get started on this final project. The final project, you pick a business. It's either a real business or it's a business that you would like to start or just something that you make up as teammates. Okay, so you basically create this business with your teammate. You're going to for the first one, write me up a description of what the business is, so what you're trying to model. You're also going to make a physical layout of the offices where you're at, okay? And what we're looking for here is having about 100 employees, okay? So you want to be able to model that. And we're going to be buying equipment for them, adding networking hardware, talking about the network challenges that this particular business would face and how you may solve them. Okay, so that's kind of where we're going, okay? So let me turn that off so I won't hear the sounds from over there. Okay, so that's where we're at on the assignment. We're going to add information to it as we go along. We're in week 2, so we have 3 more meetings after this. And on the final day, we'll be doing presentations where you'll present with your teammate through a Google Hangout. I think that's the way we're going to have to do that. Present your information about what you've been working on. Okay, so I think that makes the most sense. So again, if anybody has any questions, I see Katrina says that Patrick's added to their team. Okay, yeah, you can have 3. So that means, let me check what's going on here. Let's see. So if Patrick is going to be on a different team, then let's put Stephanie on the team with Joel and Robert. Okay, so if either Joel or Robert or Stephanie are listening, go ahead and add Stephanie Cox to your team as well. Okay, that will make some sense, I think. Okay, and then again, I'm on a delay, so I'm going to have to go back and you won't see me respond immediately to your chat because it takes about 30 seconds or so for it to come through, but I will eventually. Okay. Okay. My voice is very tired from teaching all week. Every fall I have that problem. Okay, so I will give you a second then if you have any other questions before we get started. Again, there's a new assignment on Moodle for this next, the first phase where you're doing the description of your businesses, the physical layout, things like that. Okay. So not to have dead air, I'll just talk about nothing until it's caught up. Okay, I don't see any other questions, so we're up to 7 watching, so that's a good thing. Again, these are being recorded. There's no guarantee that's going to work, but it worked okay last time. You can go to my YouTube channel and watch them whenever you want. Okay, they'll be up for the entire class, which is a good thing. So last week we talked about networking from a theoretical construct, more or less. We talked about the OSI model, which moves from the wires at the physical level. We move up to the data link layer at layer 2, which is where the network interface cards work. The data link layer is responsible for communication between connected devices. When you move up to layer 3, the network layer, it's where you first have the idea of a network, of the internet. Okay, so the whole internet is known at layer 3. We'll talk today about hardware devices at layer 3. Really make up the bulk of how the internet works. Okay, so again, the network layer is responsible for communication from one computer to another computer across the internet. When we get to the transport layer is concerned with process-to-process communication, okay? Which means not just from one computer to another computer across the internet, but from a certain process running on one computer to another. So again, if that's unclear, the difference is, let's say you're living in a dorm. Now, you guys probably aren't. This works better with my traditional students. But if you were living in a dorm or you're living in an apartment building, if the responsibility of the mail system was only to deliver the mail from who sent it to your apartment building, then there'd be no way to know which person the mail went to. Okay, there are many people live in an apartment building. So that's where we get the idea at the transport layer of processes, okay, that have port numbers. So if I'm sending something to a server and it's a web server and a database server and an email server, then by the port address, it will let the computer know either deliver this to the web server or the email server or whatever it is. Okay. So that's kind of how that works at the transport layer. Above that, you get all to things that happen on the individual computer, and that's going to be the session, then the presentation, then the application. So those 3 layers all kind of get lumped together and happen on the individual computer that someone's using. Okay. So that's where the OSI model is. The OSI model is a reference for everything we're going to be talking about. Okay. Again, if you were in a normal networking class, which this is not, you'd be expected to memorize those levels. If you work with networking at all, you will eventually memorize them because it just makes sense. But it is important in this class that you understand them because the hardware we talk about, we're going to talk about at which level it operates at. Okay, and that makes a difference because you have to know what it is that is known. Okay, when you're at the physical layer, you have a wire, either a real wire or a virtual wire, something like wireless. Okay, so the physical layer protocols deal with this moving of data back and forth. It knows nothing but the wire. Okay, when you move to the data link layer, the data link layer has the MAC address. A MAC address is a fairly long, usually hexadecimal number with colons in between it that are going to identify the individual piece of hardware. So the data link layer knows how to move from one device to another device that could be connected. Okay, and then when you get to layer 3, now we're talking about internet addresses, the IP addresses. Okay, so the IP address, we talked about that space last week. The IP address is an addressing scheme that's consistent throughout the entire internet. So it allows people to get, the packets to get where they need to go. Okay. So if you have questions about any of that, again, it's not real time. There is a delay, but go ahead and post it in the chat, and I will try to go back to that. Okay. If not, I'm going to start the notes about networking hardware. Okay. So the hardware is going to be important to you on this project because one of the things we're going to be doing, one of the big parts of that final project, is to figure out which hardware you need to buy in order to network your business. Okay, and these are practical life skills. I mean, these are decisions that you have to make if you're in the workforce, either in a position of management or just where somebody's asking you these questions. Okay, so we're going to start like we started last week with the physical layer, and that's with the wiring. Okay, I say wiring because for a lot of the history of networking, everything was based on wires. Okay, so we'll talk about wireless separately. Okay, so you have options at the wiring level. The oldest style wiring that you're going to see is called coax. Coax consists of a thick copper wire surrounded by metal shielding and all kinds of insulation. Okay, you're most likely going to see coax today if you have cable TV. Okay, the cable TV signal comes in via a coax cable. Okay, so the coax cable is heavily shielded, so therefore it's going to protect you from stray electromagnetic radiation, which could cause interference. So that's a good thing. Okay, the coax is relatively easy to install, except that it's a little bit heavy, and because it's thicker, the turning radius, you can't quite get it into as tight of a spot. Okay. It's pretty fast. It's faster than the next thing we're going to talk about, which is twisted pair. And it used to be used to connect segments of the internet together. Okay, there was a time when it was used to connect individual computers together, but that became a little bulky. That's definitely old school things that we don't do much anymore. Okay, so what is used today mostly, at least at the local level, is called twisted pair wires. Okay. Twisted pairs, there are 2 wires, and of course they're twisted, hence the name. They're actually composed of a bunch of different wires. So there are a bunch of wires together. They're twisted together. The twisting helps shield them from interference. They have a coating on them. It's not anywhere shielded as much as coax is. Okay, so they're not as immune to interference as coax would be. Okay, but they're cheaper. They're lighter weight. It's easy to make your own with some simple tools and you can watch a YouTube tutorial. Again, when this class was taught in person, we would actually make the wires, okay, or make some cables. And you basically just buy a big spool of either, the twisted pair comes in different categories. Cat 3 is like telephone wire, all the way up to Cat 6 and Cat 7, which are higher end. You want Cat 6 probably for most of your needs today, although Cat 5 sometimes works. A little bit beefier cables. Okay, you basically just get a length of wire. You're going to cut it. You're going to strip the wires, break all the little individual wires apart. You're going to shove them into a little clamp that you buy, and you use a crimping tool to crimp it together. Okay, it's important how you shove them together, but again, it's not rocket science. It's pretty rote what you're doing there. Okay, and this again is very much the most common way you're going to be connected. If you're in a laboratory, any of our computer labs on campus and look in the back of the computer, at least in the lab I teach in, they're blue, they're Ethernet cables. So that's what we're talking about. So when we talk about twisted pair, we're talking about Ethernet. Okay. Ethernet is one of the data link layer protocols. Okay. So I'm hearing beeping, but I'm not seeing anybody on the chat. So I don't know what that means. So hopefully you're not trying to chat and I'm just ignoring you. If that's the case, I'm sorry. I'm not trying to ignore you. Okay. So again, the twisted pair, sometimes called 10 base T, are not as well protected as other types of media from interference. They're also, if you're in a high security environment, you have to be cautious that people could read information passing along those wires externally by using a sensor. Okay, so you have to worry about that. Okay. The next thing up is going to be the fiber optic. Fiber optic is used nowadays to connect to bigger parts of the internet, again, network to network or across buildings. Fiber optic, unlike the others, is not magnetic. Fiber optic is based on light. It's a series of glass tubes held inside of a structure of some sort, and the light pulses travel along that. Light is very fast, so therefore that becomes a very fast way to connect. Okay, it's also fairly lightweight, but it can be difficult to install. Because it's glass, you can't just crimp it together like you would a 10 base T or a twisted pair cable, or even the coax are fairly straightforward. You just kind of jam a connector into the end. So with the fiber optics, you have to have special tools to heat the glass, melt the glass, all that stuff. Okay, so the other good news about fiber optics is that once they're once they're installed, they tend to be pretty stable. So you don't have to worry so much about deterioration over time like you could with other kinds of technologies. Okay. Of course, there's also wireless. Wireless is different in many ways, so we'll talk about wireless in a second. The two basic categories of media we have are guided and unguided. So a guided media are all the wires we just talked about, in which you know where the signal's going. Okay, if you have an Ethernet cable, it's traveling down that wire. Okay, it's not going anywhere else. It could radiate emissions from that wire, okay, but it's not going to just go willy-nilly, okay? Whereas wireless is an unguided media. With wireless, you have an access point that shoots radio waves into the air, and you have no control over where it's going to go, okay? So, one thing I was going to mention and didn't is that if the sound quality goes or you lose video for a while, it looks like it still records things properly. I spot checked the video from last week and it looked like it captured it even if you weren't able to see it. So that's a good thing. Okay. So with the different kinds of cables you have, the coax, the twisted pair, the fiber optics, which one are you going to choose? So there are some criteria that you can use. One is the cable length. There's a maximum span for each of these kinds of cables. Okay, so depending on how far you have to go determines whether you can use twisted pair or fiber optics or whatever you're using. Okay, if you have to go further than is allowed by that particular kind of cable, then you can always put a repeater. A repeater is a physical network device we'll talk about here in a second. Okay, so cable length matters. The cost matters. Fiber optic is more expensive. Does the budget allow for that? And would the benefit outweigh that? Okay. What's the bandwidth? The bandwidth is the maximum amount of information that can be passed using that particular cable. So you have to make sure the bandwidth is sufficient for your needs. Sufficient for your needs now, and you also want to think about long term. That's why a lot of times companies would go ahead and install extra fiber optics whenever they were installing any at all. Okay, when you do that, then later on you don't have to worry about installing the cables again. Okay, it's sometimes called dark wire. Okay, it's wire that's there that's not being used. Okay, so something to think about. So cable length, cost, bandwidth, ease of installation. Again, we don't do fiber optics in the local area network typically because they're a pain to install. Okay, so we don't do that. And then also susceptibility to the radio frequency interference. Okay, Again, if you're in a local environment, I know that electric machines and motors often produce magnetic fields. If you're in that kind of a situation, it may be you would have to go with coax or fiber optics. The twisted pair may suffer too much interference. And again, I'm sorry I'm coughing. My voice is still not back to normal. As far as the cable length goes, I've got a couple of things here. Twisted pair can go 90 meters and without needing a repeater, and fiber optics goes 500 meters up to a couple of kilometers sometimes. I know the entire world is on metric except us, but it seems like when you read anything about networking, it's on metric as well. Okay, so you can translate those if you feel the need to. Again, we're talking about layer one, still the physical layer. There are not all that many hardware devices aside from the wire and the actual connectors, but there are a couple. One is a repeater. Okay, remember at this level, this layer, there's no address scheme. Okay, it's all the same thing. So a repeater basically will have a couple of ports, a repeater says 2 ports. So data comes in to the repeater. Again, that data is in a series of high and low voltages. Okay, what happens if you send data too long on a wire? Those high and low voltages get closer together and it becomes indistinguishable. Okay, think of ripples on a pond. that wave eventually goes down. Okay, so what the repeater does, if it hears a high voltage coming in, it's going to transmit a new 100% high voltage. Okay, and then if it detects a low voltage, it's going to transmit that new low voltage. Okay, so that's what a repeater does. That's it, nothing else. Okay, you also have hubs. Hubs are really the dumbest network device in that with a hub, you'll have 1 port coming in and maybe 4 going out. Whatever comes in goes out all 4. It doesn't think about it. It doesn't filter it. It doesn't do anything. Okay, so you do that basically if you need to share a wired connection among a couple devices. But keep in mind, each of the devices that share with it appear to the rest of the network to be the same device, and they get all the same information. So they're not really the best option, but sometimes they're all that you can do here. Okay, so no matter what kind of wiring you use, it's going to connect to a network interface card. Okay, on most of the computers these days, it's going to be an Ethernet card. Now, when you're looking at your project, you're probably not going to have to buy Ethernet cards because pretty much any computer you buy nowadays has one built into the motherboard. Okay, so if you look on your laptop, if you look on any of your computers, you'll see what looks like a phone connector, but a little bit bigger, and that's the RJ45 jack that is the Ethernet jack. Okay, so the NIC cards you typically don't have to buy. Again, they're built in. Ethernet is a layer 2 protocol. So we've moved from the physical to the data link. Okay, so the wire that connects into the Ethernet port on your NIC card, network interface card, is a physical layer. But once it gets to the card, now we're at the data link layer, or layer 2. Okay, so the addressing scheme we have at this point is called the MAC address. I mentioned that before. Okay, so the MAC address identifies every NIC card, just the NIC card, because even the hardware further up, whether it's a router, whether it's a switch, or whatever, is still going to have network interface cards. You could have more than one. Okay, so if you have a desktop computer, you could install a couple of network interface cards. If so, each network card would have its own MAC address. Okay, the MAC address, you don't determine it, you don't set it. It's burned into the device at the factory. Okay, so you don't have to worry about that. The hardware that you see at layer 2 is called a switch. A switch has some intelligence. Okay, remember the data link layer is responsible for connecting or communications between physically connected devices. Okay, so those devices don't have to be physically connected to each other. They can go through a switch. Okay, so a switch is a smart device to some degree in that it knows this MAC address. Okay, so the way the switch operates, I wish I had a whiteboard, but I don't. But a switch is a little box. It has different ports on it. Okay, one of the ports typically is reserved for outgoing, so on to the rest of the internet. But all of the devices connect into this on different port numbers, okay? So when you first install a switch, it doesn't know anything about anything, except it knows its own MAC addresses. Each of the ports on a switch has its own MAC address, okay? So the first time it gets a request, let's say you've got 10 computers connected to a switch, a request comes in from computer number 2. And it says basically, I want to send a message, a packet to computer number 7. I don't know what number it is. I don't know which MAC address it has, okay? So the switch doesn't know. The switch will, at first, brand new switch, sends out that packet to all 10 computers, okay? So of those 10 computers, 9 of them are going to say it's not me. But that one computer is going to say, well, yeah, that's for me, okay? When it responds back to the switch saying, yes, that's me, then an entry is created in what's called the switch table, okay? So it knows from now on. It knows when someone is asking for MAC address XYZ, it knows my port number 7 goes to that particular MAC address, okay? So a switch is called self-learning, okay? It only deals with local. It's going to be, I'm going to redirect to one of the computers that connect to me, or I'm going to kick it up to the next level of the network. That's all a switch does, okay? Switches usually come in 24 or 48 port models. Again, when you're buying switches, if you need 24 ports, it's probably not a good idea to buy a 24 port switch because you know you're going to need more later, okay? And again, with switches, there are a lot of factors. And I guess I should mention where you're going to see this at in a business. You're going to see it as a connecting place for groups of computers, okay? So in the computer labs at Tusculum, all the computers in the lab are connected via twisted pair into a switch. The switch is located in a closet right outside the classroom I normally teach in, okay? So in a business setting, you're going to look, once you draw your physical layout of your business, you're going to see where there are clumps of computers. You're going to put switches in some kind of a closet, some kind of a room that connect those local computers together, okay? Switches then get connected together into bigger switches and finally into routers to take you away from your business onto the internet, okay? So when you're buying a switch, there are several factors to consider. And I am releasing these notes. They will be there, and they include some references that talk about much more detail on what we're talking about today. So certainly cost is an issue. Some manufacturers have well-known reputations. Cisco's one. Cisco's kind of the biggest name in networking. They make good switches. Their switches can be expensive. Sometimes you can get a cheaper switch, but is it worthwhile? You just have to do some work and look for reviews to see. Okay. So cost is important. You have to look at the number of connections that come in. That's important. That's called its capacity. You also have to look at the features that it has. A lot of switches are very fancy and perform almost what a router will do. Okay, so if you're looking for a basic network switch, then you can go cheaper. But if you look at the specs, you'll see a lot of different features that you can get on a switch. Okay. In addition, there are some switches that are called layer 3 switches that actually know about IP addresses. And the distinction between a layer 3 switch and a router are pretty slight. Okay. I do have a question here. Where would you find the length limits of each type of cable? Yeah, I would just do a Google search on that. Again, the twisted pair is about 90 meters, and the fiber optic is going to be between 500 meters and a couple of kilometers. Okay, I would just Google for whatever type. For a normal business, for the wiring, you're probably going to be doing twisted pair into a switch. Just make sure the switch is not more than 90 meters away, or you have to put a repeater in. And then from the switch to the router is probably also going to be twisted pair. Could be coax if it's a long distance. And then from there out, it's probably going to be fiber optic. Okay. Okay, so yeah, that's all the questions that I had that I see so far. Okay. So again, with the cost of the switch is important. You have a couple of options there, and I'm going to try to show you this diagram in a minute. If you have a lot of computers together, you can get really big switches, and some of them go into the hundreds of ports, okay? And you can connect all of your computers into that one switch, okay? which is fine. But one of the problems there, you put all your eggs in one basket in some way. If that switch goes down, there's really trouble. You're also burdening it with a lot of extra work. So usually you want to opt for smaller switches, distributed out more a little bit. It's kind of the way to go. Okay. So let's see if I can show you this picture here. Okay. But again, if you buy one switch, it's cheaper with more ports. But if you have to have longer cable lengths, then you have to put repeaters in, and your performance may suffer. And there certainly are some options there that you have to just work out the numbers. Okay. You also want to, whenever possible, if you have a network that you care about, you want to have some redundancy, which means that if a piece of hardware fails, you can find a way to work around it. Any business that does much networking at all is going to have spare switches, spare routers that are fully configured and ready to go. Okay. So this picture, my computer kind of died. Can you see this? Maybe, kind of. Okay, a little bit. Okay, so here's an example here in the top, that top, my left and right's reversed, of having one big switch with a bunch of little switches, or the computer's directly attached to it. That's going to, again, have lower cost, but longer cable lengths, okay? Where some of these others, you're going to have more of a hierarchical, where your main switch connects into sub-switches, which then connect into the computers, okay? Again, all this is going to be on Moodle, so you'll be able to look at all this in more detail, okay? So again, you look at the features, you look at the brands. In general, it's a good idea to find a brand of material or of routers and switches, stick with it. They work better together, okay? So again, when you're looking at your router, there's also some considerations for the number of ports and the speed of the ports, okay? Nowadays, you're going to get pretty much all switches support the old 10 megabits per second, the faster 100 megabits per second, and then the 1,000 megabits per second are the newer cards that you can get. So again, you don't want to buy a switch that has only 10. You want it to have the 1,000 because that's kind of where things are going. Okay, that's also called gigabit Ethernet is what the 1,000's called. So that's definitely something that you want to spend the money to have your switch be as fast as possible, even if your wiring doesn't support it yet. Okay. So, and again, when you're looking to purchase a switch, do you get just enough for now? Do you go ahead and get where you have some room to grow? Because of the cost of installation, it's usually better to install more rather than less. Okay. It's also important when you're installing network cables to keep it very organized. Okay. You want to have a way you can get little tags on them. You can get, whether they're different colors or different numbers. So because if you have a wire on one end, or you have 100 wires that go into a conduit, come out the other end, it can be difficult to know which wire is which. Sometimes that's important. Okay. Okay. So anything else at this layer? I think that's it. There's some more pictures there, but some are not. Yeah. Sometimes you can switch out the network interface cards on the switch to faster speeds as those become available. Sometimes not. Okay. So I'll give you a second, see if there are questions about layer 2. This question, do we need to find the cost for installation? No, we're not going to cover the cost of installation itself, okay? That should be a factor in your decision making, but again, if you're using twisted pair, you're going to install that yourself. I mean, you certainly, the people that work for you in any type of IT capacity can make cables. You can always buy cables if you need to. Putting together a switch is not difficult at all. Okay, when it gets to the routers between different buildings or whatever, that could be a little more complicated. But again, as a small business, you're probably going to your router will be provided for you typically by whoever you get your service from, whether it's Charter or Comcast or the phone company for a DSL. So that usually gets configured by them. So we're going to assume that we're not going between great distances where we would need fiber optics. Okay. Yeah, that was a good question. But yeah, we could do that, but I think there's enough to do in 5 weeks without that. Okay. Okay, so layer 3 gets to the real brunt of the internet. The internet would not exist without layer 3. Layer 3 is the networking layer. Okay, it's responsible for delivering packets from one computer to another computer across the internet. Sorry, coughing my head off. Okay, so for that, there has to be an address scheme that works for the whole internet. Again, we talked about the IP address. That's what does it. Okay. The hardware at this layer is called routers. Okay. So whenever you see a picture of the internet and it shows, a cloud often, but you'll have like little dots that you're connecting through. Okay. All those little dots that you're connecting through are all routers. Okay. So a router is what's going to forward things through the internet. We talked last week about packet switching networks. The idea that your email message, your web request, the picture you're sending gets broken up into little packets. Each little packet is going to be sent its own way through this maze. Well, the maze are the routers. Okay. So it's important to visualize. Again, wish I had a board, but I don't. At the application layer, you create a little bit of data. Okay. This data then, as it moves down to the transport layer, still on your computer, is going to be put inside of a bigger data structure that includes the port number. Okay. When it gets to the network layer, okay, layer 3, again, still on your computer, it gets put into a bigger envelope, let's say. This is now addressed with the IP address. Okay. That now goes down to the data link layer. On your network interface card, it's going to be put into something a little bigger called a frame. So the frame contains the packet. The packet contains the transport layer information. The transport layer information, that's called a segment. The segment contains the actual application data. Okay. So as it travels through the internet, that frame at the data link layer that gets it from one device to the next device down the line is going to be discarded and redone every time. Okay. But the other information, okay, the packet and the segment and the application data stay the same. Okay. It's going to be there all the way through in most circumstances. There are times if you get a particular part of the network that can't handle something that big, it can be broken up, but that's rare. In general, the application, the segment, the packet. So the application data is inside of a segment. The segment's addressed with the port number. The segment's inside of a packet. The packet is addressed with the IP address. It's going to go all the way across the internet. Okay. So what does a router do? A router has to have, by definition, multiple NIC cards. Okay. So it's going to have input cards and output cards, and those could be the same ones can do both. Okay. But basically, when it receives information from one of its ports, it's going to be the network interface card of the router is going to check the frame, make sure the frame's legitimate. If it is, it's going to discard that information. It's then going to read the layer 3 information, the IP address. Okay. It then has a routing table that says, if the IP address is in this range, send it out this port. If it's in this different range, send it out this port. If you don't know, send it out this port. Okay. So every router has multiple input ports, multiple output ports. When something comes in, it's going to read the address. Its routing table is going to tell it which way to go. Okay. Unlike switches, routers do not self-configure. So when you install a router, you have to configure it yourself. Okay. The routing algorithms themselves will change over time, reflecting the current conditions. Okay, so as things get slow over one link, it'll route them around the other link. That's why we will often say that if you have a picture you break up into packets, it probably won't follow the same path. Okay, so those routing algorithms are not set in stone. Okay. So let's see what I didn't talk about that I should have. Okay. Okay, now I can't do a screen share, so I was going to do a drawing of that, but I can't. There's plenty of stuff online. If you're having trouble visualizing what I just talked about, then definitely let me know, and I will put up a chart or a graph of some sort. Okay. So factors to consider when you're choosing a router. Okay. You want to make sure that the router meets the purposes that you're trying to do. You don't want to get too much or too little. So again, the cost, the interface types, and the speeds are what you should consider. Okay. In addition to that, you want to think about the expandability the media that it supports, and the operating system features. Okay, so for the expandability, they have both fixed and modular configurations. So for some, you're stuck with the number of ports you have. Others allow you little add-on modules to add more ports. So that's something that you can, if you have to expand later, you don't have to buy a whole new router, which can be a good thing. Okay, let's see. That's expandability, if that's a good thing. The media just does it allow you to connect if you're doing coax, you're doing fiber optics, you're doing twisted pair, whatever it is. It has to have the media for that. Okay, if it doesn't support it, then it's not going to work for you. You also have a lot of different operating system features. Okay, so a hub is an electronic device only. A switch has some processing power to it. A router is pretty much a full-fledged computer. In fact, you can take an old computer, you can take a new computer if you want, and turn it into a router. Okay, they're just computers. They have an operating system. If you have a router at your house, then it's probably running Linux. Linux is pretty popular on those little devices. It's a regular computer in many ways. Okay, it's stripped down, but it is a computer. So the operating system is going to matter, and it's going to have some different features. The features there that we're looking for are things such as security. You often get at routers, you get where you're looking at the packets and you're determining which packets are good and which ones are not. So packet filtering, that's the word I was looking for. Packet filtering is an important concept. Okay. In these notes, I almost went off on security, but we have a whole different day on security, so I'm not going to talk about that too much. You also have quality of service. Quality of service, or QoS, deals with can the router guarantee certain levels of security or not. And again, depending on the application that you're using or the application that you're doing, then it can be difficult to guarantee that bandwidth. You can never totally guarantee, but you can more than others. Okay. Some of the routers support voice over IP. A lot of times for a business, instead of having the traditional phone system, you'll have an internet-based phone system. If you're going to do that, it needs to be supported by your router. Okay. If your router doesn't support it, it doesn't do you any good. Okay. Sometimes you'll need to route multiple layer 3 protocols. Again, on the internet, the most common layer 3 protocol is IP. It's not the only one. So if you have a business need to do some other local version of networking, then you have to make sure your router supports that. Okay. There are also special services such as network address translation, which I think I will talk about in a second here, and also dynamic host configuration protocol. Okay. So let me go ahead and talk about those. I don't know if I have a separate part of that or not. I should if I don't. Okay, what network address translation does, in fact, I may have talked about that last week. I'm trying to think about it. A network address translation allows you to share one normal real IP address with multiple devices. Okay, so if you ever look at your local router at your house, it probably starts with a 10.0.0. something. Okay, typically 10.0.0.1. Okay, and you may wonder if you're at a friend's house, their router has the same IP address. Well, that's because that's not a real IP address. That's a NAT protocol, network address translation protocol IP address. Okay, so your router itself has one real IP address that goes out to the internet, but it uses these local NAT IP addresses, the 10.0.0. whatever, to address local devices. Okay, so from your ISP you get one IP address. Okay, but if you have, right now, I'm running 2 laptops. My wife's probably running her laptop. We only have one IP address. How does that work? It works through the NAT protocol, NAT, N-A-T. So it basically assigns one of these 10.196 is another one you see a lot. Okay, 196.128. whatever. Okay, those are locally routed, and they actually use the port numbers, which is a next layer up, a layer 4 protocol, to keep track of things. Okay, so if something comes into, with the same IP address as the rest of your network, it'll have a different port number, whether it's meant for, this laptop or that laptop or whatever. Okay, so again, that's a way to expand the number of IP addresses that you have. And the other thing that's useful is called the Dynamic Host Configuration Protocol, or DHCP. What DHCP does, it allows you to define a pool of IP addresses for your business. Okay, and then whenever somebody logs in, it's going to pick one at random. The value of that is that if two people try to share the same IP address, it's going to fail. Okay, and I didn't say this before, but I should have. IP address is user configurable. Okay, so you type in your own IP address, basically. It has to work, has to be valid, but you can change that for whatever range of IP addresses that you have. Okay, so by having this dynamic host control protocol, it allows when a user logs on, they can pull a valid IP address from the pool, okay, which works for that session. So that's a good thing. The alternative is pretty awful. When I worked at Northeast State several years ago, quite a few years ago now, the network manager kept all of the IP addresses in a Word document. So whenever you wanted an IP address, he had to go through and try to figure out what they had available. It was not a good system. It was very difficult for him to manage. Okay, I'm hoping by now they've gone to DHCP. Okay, so those two things, again, are implemented at the operating system of your router. Okay. The other thing we're not going to talk about in this class much is the idea of subnetting. And subnetting is a way sorry. Subnetting is a way to divide the network space you have into smaller networks, okay, for some routing information. Okay. So again, this is not a full-on networking course. We don't talk about it, but there are some things out there on the web if you're curious, if you do networking in your job much. Okay. So when you're actually connecting these together, you have to look at the physical layout of the building, see what you're doing, see how many computers that you have to connect. Okay. There are 4 areas you want to consider here. Okay. The first is the work area itself. So this is where the computers are located. You may have one work area with 100 users. You're probably going to have multiple work areas. Okay, so you have to connect the computers together in those work areas and then connect the work areas together. Okay, you also will need a telecommunications room. That's often a closet that's been repurposed. It could be just a small room somewhere. It could be a larger room that if that larger room is located adjacent to a bunch of different of the work areas. Okay, you need the backbone cabling, which is known as vertical cabling. The vertical cabling is going to connect the bigger parts of your office together, and finally you have the distribution cabling, which is going to take you out of the business. Okay, so we'll go through these in a little more detail. Again, the work areas themselves. Okay, this is where the end users are going to be. This is going to be the offices, the workrooms, if there's a bigger rooms, whatever, where people are, okay? So you typically want to have 2 jacks in each area when you're running them. When you buy, there are jacks that look like, you've probably seen these, that look like a little plug, like electrical plugs, that have a couple of different jacks in there. Makes sense to do that when you're doing that, okay? When you're putting them in, put in 2, because sometimes you'll want a laptop and a desktop. Sometimes you'll put 2 people in the same office, okay? So you want to have patch cables will then connect from the device to the wall. So you'll have wall jacks here, which is useful. Okay. Those then get connected into the telecommunications room. The telecommunications room is where your switches are going to be. Okay. You could also have routers there. You could have hubs if you're using those. Okay. So these are often rack mounted if it's a fairly big business or a fairly big organization. Even at Tusculum, in the computer room in Bird that I teach in most of the time, there's a rack with a couple of switches and a router because it connects in all of that first level of Bird all come into that room. Okay, so with those rooms, you have to be careful that they have reasonable heating and cooling, that they're protected from moisture, things like that. Okay, so these rooms should also be off limits to people. They should require a key entry to get in. You don't want people messing with this stuff. Okay. Then the horizontal cabling refers to the cables connecting the telecommunication room to the work area itself. Okay. So again, that's going to be a way to get from the telecommunication room to all the different areas. And sometimes you'll have a switch in the local area, and some depending on the distances. And sometimes the switches will be located in the telecommunications room. It just depends. Okay. Then you have the backbone cabling, which will connect the telecommunications room to the outgoing equipment room where the routers that were provided by your ISP are located. Okay, the number of layers of networking that you have really depend on the size and the physical layout of your business. Okay, a place like Tusculum is probably going to have a router per building. Okay, it's going to have multiple switches, again, depending on how big the building is and how it's laid out. Okay, the switches connect into the router at the building level, and then the building routers then connect to the giant equipment room that's in Niswanger that then connects out to the ISP. Okay, so then the horizontal, again, think of your business here. You're dealing with all of the connections between your business thing. Those are horizontal cabling. The vertical is what's going to go. We often represent the internet as a cloud. So the vertical cabling goes to the cloud. Okay, basically, that's what we're talking about here. Okay, so I think I have a picture of that as well. Again, these are in the notes that will be online, but I can try to show you this as well. Hopefully it's visible. Okay, so here's a picture. Let's see if we can get the parts here. It starts over here with the telecommunications room. Yes, no, maybe. My right's left again. Yeah, over here we have the telecommunications room where there's a switch there. There's also a patch panel which just connects wires in. Okay, the horizontal cabling is here. It connects you over via a patch cable to the work area. Okay, so the telecommunications room over here, the switch is over here. It connects over to the work area here. Okay, then that's the horizontal. The vertical is where it's going to go over to the rest of the internet, basically. Okay, and again, I know that's hard to see, and I apologize for that. I looked online and found some advice from Cisco. Again, Cisco is one of the bigger manufacturers of networking equipment. And here's some advice on building a small area network. When building a small office network, it's important to determine the best foundation for your company's needs. Following tips should help get you started. Invest in business-grade switches and routers for reliable communication. Consumer or home networking products can't keep pace with the challenges of business growth. And that really is an important factor. Okay, so you don't want to go to Walmart for your business and get a router there. Okay, you could, may work short term, long term it's not going to be what you need. Okay, invest in a network that can grow over time. You can add features and functionality as needed. Additions to consider include video surveillance, voice over IP, integrated messaging, and wireless applications. Okay, so that's important to consider. Again, hopefully you're not going to be a small business forever. I mean, maybe you are. If you know you're a mom and pop that's always going to be a mom and pop, then that's different. But most businesses want to grow. Another tip, make sure your switches and routers are easy to install, use, and manage. So example would be switches with an inline power allow you to place equipment such as wireless access points anywhere there's a network wall. Okay, a wall jack, sorry. That was not making sense to me. You'll be spared the trouble and expense of installing additional electrical outlets or wires to power the devices. Okay, so again, if the switches have where you can plug devices into them directly, that just helps you out. Okay, make sure your network is designed with reliability and redundancy in mind. This provides the business continuity you'll need to bounce back quickly from unforeseen circumstances. Again, so yeah, you want to have extras, you want to have extra capacity in your system. Okay. And there's a Microsoft link in the reference section of the notes I'm going to post on Moodle that has a lot of good information about planning and drawing out how to do the network diagram as part of your final project. Okay, so I recommend that you go to that link at the bottom of this series of notes, click on the one that goes to Microsoft, read through that. Some good information. There's a ton of information online. A lot of information on Wikipedia. I know in some of your classes Wikipedia is frowned upon. When it comes to computers in general and networking in particular, I found the information to be very good. Some of these notes come modified, but come from Wikipedia. So good stuff. Okay. So wireless networking. Again, we've avoided it until now. Wireless networking is very important for both for businesses and individuals as well. Okay. The problem with wireless is that because it's unguided media, you can't control where it goes. Okay, so if I'm a business and I set up a wireless router for my employees, then I can't control how far the wires go, at least not practically. Okay, so that's difficult. Okay, but wireless is also extremely convenient for people. Okay, so pros and cons. Okay, so again, it's a series of radio waves that go through the air, and there are opportunities and challenges with this. Okay, now the types of wireless networks, there's a bunch. The ones we care about most, um, the wireless personal area network, or PANs, WPANs they're called, are very popular, and that's Bluetooth. Okay, Bluetooth is great. I have a Bluetooth speaker, so I can listen to music or whatever I'm listening to from my iPhone without having to connect a wire. That's good. Bluetooth's good. Bluetooth is really short range. Okay, it's not used for data typically, like as part of a bigger network. It's just used to connect your device to something really close by. Okay, so when we talk about wireless, we're typically talking about a wireless LAN or a wireless Ethernet. Okay, wireless Ethernet is kind of a misnomer. Okay, wireless Ethernet has no physical or technological connection to regular Ethernet. The reason it's called wireless Ethernet is because Ethernet is a standard term that's used in networking. Okay, all of these are determined by IEEE specifications. Okay, the wireless is 802.11. So 802.11, if you look those up, you'll see the different levels of a wireless network. Okay, so 802.11 standards go into a bunch of different subgroups depending on which kind it is. Okay, so here is another photograph or another chart. I'm sorry, they're hard to see here, but basically you start with the internet. See, you can see that, yeah. The internet's out here. It's usually a cloud. The internet's going to come in. You have to have some kind of a router. Okay, for the wireless part, that router connects over to this wireless access point. Okay, the wireless access point has an antenna. It's going to broadcast out. So you have a printer up here that's connecting wirelessly. You have a couple of laptops that are connecting wirelessly. A desktop computer there is connected by a wire. Okay, so just because you have a wireless network doesn't mean that you have to have a wireless network only. Okay, so if you buy a router for your house, that router is going to have physical ports and also the wireless. Okay, so you have to think about both of those. Okay, so the wireless, depending on which level or which kind of wireless it is, level A, B, I think G, maybe, no, N's the current one. Wireless N goes further than G did and has better quality. Okay, so definitely those are things that are worth considering. Okay, how far it goes. Okay, so let's see. That's all the standards. Performance is an issue. Wireless is never as fast as wired. It just can't be. It's theoretically not possible. Okay, so therefore you have to consider that in the equation. For example, I have a Roku. If you've never heard of Roku, Roku is a device that connects your TV, a non-smart TV, to the internet, so you can get Netflix and things like that. Okay, the Roku that I have could be connected via wireless, and we used to do that. When we connected via wireless, we often had significant delays. Okay, so my cable modem's close enough to the television I use most of the time. I connected my Roku in via wire tons faster. Okay, so again, it's because of the radio waves through the air, the possible interference and all that, that it's slower. You also have to think about more security and because anybody can listen to it. So it differs a fair bit. Okay. So they are getting faster, but you do have to still be concerned about that. One thing to consider, before, when I would buy a home router until about a year ago, I would buy the cheapest router available, which would always be one level down from the current standard. So when G was the new hot standard, I bought the B because that was the one that was cheap. Okay, you pay for that in performance. Okay, so this last time I thought I use the internet enough, it's worth buying a better router, so I bought the N. But in addition, I bought a mid-range N router, not the cheapest. It has 2 different antenna systems, 2 different connections, and it's tons faster. So you really do get what you pay for. So spend what you can. And the same is true if you're looking at your business. Okay, it's an open question whether you should have wireless at all. Okay, so I guess before we get too much into that, it does make some sense that you think about that. Wireless allows, even with a password, and even if you hide it, it allows the potential for people to hack into your network without you knowing it. Okay. The upside of wireless is that if you're in an area where it's difficult to wire, then that could be a problem. Or if your employees have a legitimate business reason to be using their cell phones or tablets, and the 3G or the LTE is not good in your building, then you kind of have to do something about it. Okay. But there are definitely trade-offs. Some businesses do not have wireless for that reason. If you're going to provide wireless to the public, it's a whole different level of heartache, the things you have to figure out. Okay? So, let's see. Someone said AC is the fastest at this time. It may be. The last time I bought a router was in. I haven't checked. Those change constantly. So again, when you're looking for routers, look to see what the current standards are. They're always moving forward. Okay? And you do want to get the fastest that you can. Okay. Okay, so if you open up wireless for the public, you probably want to separate that entirely from the rest of your networks. Okay, so nobody can get into one then get into the other. Okay, it can be a problem. Okay, so again, if you have difficult to wire areas, if you're trying to have employees that roam, they have to roam. If you have a tablet that somebody in a warehouse is going to go from room to room, you have to have wireless. There's no way to avoid it. Okay, you just have to deal with the risks. Other times, you don't want to do that. Okay, again, at the home, it certainly makes more sense to have wireless. You don't want to be connected all the time, even if it is faster. If you have multiple devices, it can be difficult to manage. Okay, so again, one of the big issues here is interference. We have interference problems with wires. There are even more interference problems when with wired. With wireless, there's even more. There's even more stuff in the air, okay, that can cause problems. Okay, so some of that's caused by other networks, could be caused by other types of equipment. Lots of issues to deal with here. Okay, so because of that, that adds to the speed problem because you have to add more redundancy. You have to have more reliability checks because it's just not assumed it's going to happen. Okay. If you're going from one computer to another computer via physical copper wire, the odds of something going wrong are not real good. It's going to work almost all the time. When you talk about wireless, then you have a whole new layer of complexities to deal with. Okay. Other issues that you have, absorption and reflection. Some materials will absorb the electromagnetic waves and not allow them to pass. Sometimes they'll reflect off and pass further than you want. So maybe somebody a long way away from you can get onto your Wi-Fi, and you don't want to do that. Okay. In general, they have found that if you have aluminum foiled thermal isolation in a lot of modern homes, will really reduce the signal throughout your house. Okay. Also, if you have metal studs in your house, it reduces how things work. Or in your business either, it can reduce how things work. Okay. If that's the case, you just want to put in a separate wireless access point in different parts of your business in order to accommodate that. Okay. There's also a problem called multipath fading, and that's where you send out a signal and it's going to take two different paths back to the other end, and the receiver is going to get two different messages from two different locations. I'm sorry, the same message from two different locations at different times. It may cause it to be confused. It may think there's an error and may reject one or the other of those. Okay, so that could be trouble. Okay. There's also a problem called the hidden node problem. Okay, and that occurs where one access point can see another access point, but it can't see a third one. So the communication can get really confusing. So here again, a picture of this where A can see B and B can see A, but A can't see C. Okay, so therefore you have difficulties when B assumes that A can see C, but C can't see, but A can't see C. Okay, so again, that's something, especially here in the mountains, can be difficult getting your wires around things. Okay. Okay, we're coming down toward the end here. Not too much longer to go. I see that Katrina has to go, and that's perfectly okay. This should be online, assuming the recording goes well again. Okay, so there's also a shared resource problem in that the bandwidth is limited, as you get more and more people connecting, then it's going to overwhelm and slow down the network. If you've ever tried to use the wireless on Tusculum's campus, they have wireless across most campus now, that's a problem. To address that somewhat, they have two different networks. One's the student network and one's the staff network. So basically they're trying to keep the students off of the staff network, which is then faster just because fewer people are on it. Okay. Again, security, I had a whole bunch of stuff on security. I weeded most of that out, but it's disingenuous of me to talk about wireless without talking about security a little bit. Okay. Preventing unauthorized access to your network is much more difficult when using wireless. Okay. Again, I can drive up to your business and be in the parking lot in a public area, whip out my laptop, whip out my phone, and I can see your network through the walls, in the air, and with some pretty simple tools I can hack into your network. Okay, so there's some problems there. So there are two common types of security now out there. The first is called WEP, for Wireless Equivalent Privacy. The other is called Wi-Fi Protected Access, WPA. WEP is of no value whatsoever. WEP can be broken by free programs you can get from the internet in a matter of seconds. If you go to your home router, and you should, and you see that it has WEP enabled, either turn it off. There's no point having it. It's worse than nothing, I think. Well, that's not true. It may keep your kids out of it or your kids' friends. But you want to be using WPA, okay, or the Wi-Fi Protected Access. We're currently up to WPA 2. That's the best. If your hardware supports it, do it. If not, do the WPA. If you're stuck with WEP only, then assume that anybody who wants to can get into your wireless network. Okay. So there are some other problems. Even if your business does not have wireless, it may decide that wireless is too risky. It doesn't mean that you don't have trouble. The trouble comes in that most laptops come pre-installed with wireless technology. It's turned on by default. You don't have to do anything. Okay. There's also, at least it used to be in Windows. I think they fixed this by now. But by default, it turned on ad hoc networking, where a computer would attach not to a wireless access point, but to another laptop or another device. Well, that's a good thing in general, but it's not something that you want to leave turned on. So that led to one of the bigger hacks that we've seen, at least that we've heard about, through TJ Maxx. With the TJ Maxx hack, a hacker was in the parking lot near a TJ Maxx store. TJ Maxx had no wireless at all. No wireless access point for their employees, none for the public, okay? But they did have laptop computers that were in default in promiscuous mode. And you can guarantee promiscuous mode just doesn't sound good, and it doesn't. It means basically that without warning the user, sorry, my nose is itching off with allergies this year, without asking the user, it will allow an outside computer to connect to the wireless card of the laptop, okay? So there were employees of TJ Maxx inside the store, in the business office, that had a laptop, that had a wireless card, wasn't connected to any wireless Ethernet at all, just was there, but it was in promiscuous mode. The hacker saw that. You can scan there. You can hide whether or not your broadcast name is out there on your router, but it doesn't stop someone who's doing a spectrum search. Okay, so they found these cards. They made the ad hoc connection request. Once they were there, they were now in the TJ Maxx network and were able to get to the credit card information and all kinds of horrible information for the company. They basically went from the local to the national, again, because they were on a protected link, and at that point were able to steal all kinds of stuff. Okay, so it's important that you, if you have laptops and you're not going to use wireless, it's important that you disable the wireless cards, which you can do, but again, not by default. It's also important that you double check the version of Windows you're using to make sure that it does not allow this promiscuous mode to be turned on. Okay, and you need to make sure your users are aware of that as well. So again, there are some issues that you have to consider. Okay, lots of security concerns with wireless, and we'll talk about that more when we get to the security section. Okay, so there's a few more things in the notes, a little more detail if you want. There's also a reference section at the end with a lot of good information. Okay, and there's plenty of stuff out there if you want to take a look. Okay. One last thing before I'll ask if there are any questions today, and this is kind of a bonus that doesn't relate to the class. We talked about wireless routers for your house. They're a good thing to have. Even if you have one computer that you directly connect into an Ethernet cable, a wireless router is still a good thing because, in essence, when you have a wireless router, it's on the internet and your computer is a little bit abstracted. Okay, so you have a layer of security. Oftentimes, a firewall, which we'll talk about later, it's a way to do packet filtering of bad information to not allow certain connections in. There'll be a firewall built into your router, okay, which is a good thing. Adds extra protection. Okay, it also allows you to share your Ethernet among devices and to have wireless, which can save money on your data plan on your smartphone and your tablets. Okay, but it's also important if you have a wireless router. Sad but true, any manufacturer is going to have the same IP address. Okay, it's usually 10.0.0.1 or 192.168.0.0 or 0.1. So if I'm sitting somewhere and really wanted to get into someone's Wi-Fi and I didn't care about the legalities of things, I would look for those IP addresses, try to connect to them. It would allow me. I could then log in if I had the login and password to the router. Sadly, the login and password for different routers is standard. There's a default. So on some systems, it's admin. I think the Linksys maybe, it doesn't matter. Different ones have admin for the username, password for the password. I mean, these are not difficult to know, and they're the same for every device of that type. So, therefore, you don't get a lot of security from that. So what you should do today, log into your network, okay? Make sure that your WPA and WPA2, if it supports it, into your router, make sure that's enabled. Make sure you have a reasonable password. It's not a bad idea to set up a guest network if you have friends that come over, if you want to segregate that out, okay? But definitely change the password on your router. If not, somebody, your neighbor, somebody down the street, somebody in your driveway or out in the street near your house could log into your router, change the password, lock you out, use it for themselves, okay? Of course, there are ways to get over that, but you don't want to do that, okay? So that's all I have on network hardware. If you have questions, go ahead and be typing those in. Again, the Moodle assignment's out there. I think that the initial business write-up is due on Wednesday. Double check Moodle to make sure I'm telling you the truth. But that was my plan, to have it due this Wednesday. Okay. Your teams, let me read that again in case people weren't here. I did add some, let's see, where's that at? It was somewhere. There we go. So Katrina, Orville, and Patrick, I think, are in one team. So Arnold, Steve, and Stephanie will be in. No, that's not what I said. Arnold and Steve are a team. Joel, Robert, and Stephanie are a team. And Billy and Cynthia are a team. I think that's correct. If that's not correct, then definitely let me know. Okay? So I'm going to wait around a second and see if there are any questions. If anybody wants to talk on Google Hangout, we can switch to that as well. Just let me know. I will wait for the comments. Okay, I'll turn up the other computer so I can see what I'm doing here. Yeah, someone asked about the individual paper. I can certainly speak to that. Okay, the individual paper is just going to be a topic that interests you in the world of networking. Okay, it's really open-ended. It could be something that relates to your business. It could be something you're just interested in. Okay, I will put up a Moodle assignment for that with more detail. I think in the past it's been 3 to 5 pages. Okay, but you just want to research something that goes beyond what we talk about in class. Okay. Did that answer your question? If so, let me know. If not, you can ask a follow-up question. Okay. Is there anything else? Okay, apparently that answered his question. That's good. Anything else you need? I didn't have virtual office hours last week. It was a crazy week in general, but I can certainly do that this week. So I will. I'm guessing. Let's say, I don't know, Tuesdays at 8 o'clock as a possible time. Okay. The 9 or 10 doesn't matter to me. Cynthia asked that question. We can keep it at 9. I'm okay with that. If there's strong feelings about 10, I remember now we switched that because when we met the first and last class, a lot of people had to drive a long way to Morristown. They didn't want to have to get there at 9 o'clock. So, okay, we got 1 vote for 9. If anybody else has any strong feelings, please put them in the comments. It really does not matter to me. And you see that today's normal and that it's going to take an hour-ish, I would say. Wish my screen wouldn't go blank. 1 vote for 9. Tuesday's not a good day. Well, okay. Why don't... those are not required at all. That's just for individual meetings, and I can meet other times. In fact, people tend not to do the virtual office hours anyway. So why don't we just say, if you want to talk to me, send me an email or send me a message. You have my cell phone number on the syllabus, and we can set up a time to do a Google Hangout. That's probably the easiest way. Remember, I'm also in my office physically Monday through Thursday, usually at 8 in the morning till my class at 8:30, but more often or always from noon until 2:30. Sometimes I have meetings. Sometimes I'm there later. So if you're going to be stopping by, and someone said they were, I think it's Robert, but I don't remember 100%. If I know exactly when you're coming, I will make sure I'm there or let you know I've got something else I have to do. Okay? Okay, looks like 9 is the consensus. I think that's probably better. That gets us out of the way by 10-ish, 10:30. We can go on with our day. Okay? Are there any other questions or any need to go on Google Hangout right now? I'm sorry, there are delays. I have to make sure you've heard everything before I can go on. Are there any other questions or any need to go on Google Hangout right now? Okay, so yes, you got to hear me hearing myself and all that. Okay, so Robert has a question, who's in his group? Let's see, let me look it up here. Robert, you're in a group with Joel, who's also online here at the moment. Okay. Okay, are there other questions on anything? And yes, I will take a look at what you've submitted and give you some feedback on that. Okay. This class is very much end-loaded in that we're building toward this final project. As long as the final project's good, it doesn't matter as much what it looks like along the way, if that makes any sense. Okay. So is there anything else we need to talk about? So again, the office hours will be when you need them. Just let me know, and I will try to accommodate. Of course, I'm not available 24/7, but I am available multitudes of times, so we can figure something out. Okay. Let's see. Where is Mandy at? I could be totally confused. I have Mandy nowhere. That's really sad. Yes, Mandy can be in that team as well. That would make sense. So Joel, Robert, and Mandy are a team. I better type that up or I'm going to have all kinds of trouble. Okay, so I have Katrina, Orville, and Patrick as one team. Okay. Then I have Arnold, Steve, and who? I don't know. Stephanie. Is that right? Okay. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm missing somebody. Okay, so I've got Katrina, Orville, Patrick in one team. I've got Arnold, Steve, and Stephanie in one team. Joel, Robert, Mandy in one team. And then Billy, Cynthia, and whoever's left. Who is left? I don't know. There's one other person I don't have. If you're that person, and I'm not picking out who you are right now, then you'll be in that last team, okay? And if that's wrong, just... Okay, yeah, I've added somebody else to your team, Steve, basically, I think. Yeah. Okay, so hopefully that was correct. If not, send me an email. Okay, everybody send me an email with who your team is, and we'll make sure everybody's in a team, and we'll go from there. I just want everyone to be on the same page, okay? What else do we have here? No, the project is a group project, so there's only one submission. So there's an individual paper, and then there's the group project, okay? The group project will come from everybody, okay? Then as is typical for a group project, I'll want an individual write-up of what you did, what the other person did, what problems you had. But as far as the assignment itself, okay? So every team should have 3 people, I guess is what we're coming down to, unless people have a reason to do otherwise, okay? Anything else? I'm just listening to make sure that I've caught up here. Okay, looks like there is nothing else. So not hearing anybody want to go to a hangout right now, that's good. We will just plan on meeting next week, same time, 9 o'clock, which is what seemed to be the consensus. Again, I will, if you need to talk to me individually, either come by my office, send me an email so I know when you're coming, so I'm sure to be there. I'll let you know there's a conflict. Or just send me a text message that you want to either text or Gmail, or we can Google Hangout, whatever you want to do. Okay, if there's nothing else, then this should be available online immediately. And if there are problems, let me know. I will see you guys next week.